Transformations of functions. As you advance through higher math courses, it becomes useful to be able to make quick sketches of graphs without plotting points or using a graphing calculator. Some common functions in their basic form, called parent graphs, should be memorized. And here are 6 parent graphs that are very common that you should be able to just draw a sketch of their shape when you see the basic form. The linear y equals x is just a diagonal straight line. Quadratic is a parabola anchored at 0, 0. Notice it's y equals x squared and there are no numbers or pluses, minuses, anything around the x squared. It's the most basic form of the graph. Absolute value makes a v anchored at 0, 0. The cubic y equals x cubed. When I draw it, I think about drawing a smile on the right side and then a frown on the left side, a half smile, half frown. And I think that makes it a little bit easier to draw. The square root starts at 0, 0 and slowly slopes up. And then the cube root is kind of that sideways curvy thing there. Now, when numbers are added, subtracted, or multiplied to the parent graph, the graphs move, rotate, stretch, or shrink. And so that's what we are referring to when we say graphical transformations. We're taking the parent graph and changing it in some way. So this gives you a guide as to what happens depending on where numbers or pluses or minuses are placed around the parent graph. The F just stands for whatever function we're dealing with, whether it's an x squared, an absolute value of x, or whatever. On the outside, if there's a minus, then that is a vertical flip. The graph flips over up and down. And that might be called in some books a reflection over the x-axis. And then if there is a number being multiplied in front of the function and it's greater than 1, it's a vertical stretch of that amount. If it's less than 1, it's a vertical shrink of that amount. The parentheses represent values that are trapped inside the function. For example, they might be trapped inside absolute value bars, or trapped inside a parentheses, or underneath a square root. So if there's a minus trapped inside, that's a horizontal or left-right flip. And so that would be sometimes called a reflection over the y-axis. A number multiplied inside the function is a horizontal stretch or shrink, but it's kind of backwards of what you would think. If b is greater than 1, it's a horizontal shrink. And it's not of b, it's of 1 over b. If b is less than 1, it's a horizontal stretch of 1 over b. Numbers added or subtracted inside the function move the function left and right. And that's also backwards of what you might think. A plus moves the function left, a distance of c divided by b. A minus moves the function to the right, a distance of c divided by b. If a number is added or subtracted outside of the function, that's the d value, and that is how you would think. Plus is up a value of d, minus is down a value of d. So we're going to do several examples using this so you'll kind of get the hang of what I'm talking about here. Now first let's look at what happens when we have our number added or subtracted to the back. The first graph you see is the parent graph for y equals x squared, the parabola. The second graph, outside of the x squared, we have a plus 2. So that would be a d value. And if it's plus 2, that means we're moving up 2. So now my function, I take my anchor point, which was at 0, 0, and it gets moved up 2, and then you redraw the parabola. The third graph is a minus 2. So that would be down. So my anchor point at 0, 0 moves down 2, and you redraw the graph. Now these graphs I did on a graphing calculator just so they would look nice, but the idea is just to draw a quick sketch by hand. If we are adding or subtracting inside the function, like the bottom graphs, that's going to move the graph left or right. So the middle graph at the bottom, a plus 2 trapped inside the parentheses, that would be the c value. And a plus moves the graph left, a distance of C divided by B. 2 divided by 1 is 2. So it goes to the left. And then the last graph, a minus 2, we'll move it to the right, a distance of C divided by B. 2 divided by 1. So the graph moves to the right, 2. Negatives cause the graphs to flip over. So the first graph is just the parent graph for y equals the square root of x. The second graph has a minus on the outside. A minus on the outside causes a vertical flip. So my graph flips over across the x-axis. On the bottom row, again, you see the parent graph, and then the last graph, there's a minus inside the function. So that's a horizontal flip. It's flipped over the y-axis. Numbers multiplied to a function cause the graph to stretch or shrink. So for this example, y equals 4x cubed. That number is multiplied on the outside. That would be the a value in the little guide that was a few screens ago. So if a is greater than 1, I know it's a vertical stretch of 4. And so what you'll want to do for a stretch or a shrink so that your teacher will be able to tell that you've stretched or shrunk it. First, draw a sketch of just the parent graph. So let's say that this was x cubed. Smile on the right, frown on the left. Now, a stretch means the graph is being pulled from above and below. I always think of the arrows of the graph like little hands. So if I pull from above and below to stretch it vertically, that's going to cause the graph to become more narrow. And for me, to show me which one of the two graphs you've drawn is the final answer, put stars beside your final answer so that I can tell if you've made the graph more narrow or more wide. So a vertical stretch makes it more narrow. For the second example, our a value is less than 1. So that is a vertical shrink of 1/4. So again, do a sketch of the parent graph. And then a vertical shrink means you're pushing down from above and below. You're squashing it. So that's going to make it bow out more wide. So vertical stretch makes it more narrow. Vertical shrink makes it more wide. Now, for the vertical stretch, for example, the larger a is, the more narrow it becomes. But that's not what we're trying to do here. We're not trying to get it exact. We're just trying to get a quick sketch of what the graph looks like. So if you'll draw a parent graph and then draw something that's more narrow than that, then that will be good for what we're doing right now. If the number is multiplied inside the function, like this 4 is trapped inside the absolute value bars, then it's the b, and it's going to be a horizontal stretch or shrink. So when b is greater than 1, it's a horizontal shrink. And not of 4, you flip the number over. So of 1/4, a horizontal shrink of 1/4. And you need to write what's happening with the transformation. So you need to write all those words. Parent graph, its absolute value, that's a v, anchored at 0, 0. Horizontal means left and right. So a horizontal shrink means you're pushing in from the left and from the right, which will make the graph more narrow. And then we put stars by our final answer. The bottom one, 1/4, is the b value. And if it's less than 1, if b is less than 1, it's a horizontal stretch of, and you flip b over, horizontal stretch of 4. So again, here's the parent graph. The horizontal stretch means it's being pulled apart from the left and the right, so it will be more wide. And again, we're not trying to be super accurate. We're just trying to get a rough sketch, a rough idea, a quick drawing of what's happening. If we need to be more accurate, that's when we would plot points or use a graphing calculator. But the idea here is a quick sketch. Now we're asked, describe describe how the graph of each function can be obtained from the graph of f. So we don't know what the function is exactly, but we can see the numbers around it, and it's asking what's happening to our function. For the first one, this minus 5 is a subtraction outside of the function, so that would be d. And we know if d is a subtract, that means down 5. So that's the description, and that's all we need to do for that. For the second graph, or the second example, first the 3 is a number being multiplied on the outside. That means that's A. We have a minus on the inside. I know that's a horizontal flip. Invisible 1 would be B. And then the 2, since it's trapped inside the parentheses, would be C. Now I need to write down what all is happening. A is greater than 1, so we'll say a vertical stretch of 3. And we already wrote horizontal flip. And then since B is 1, 1 doesn't do anything. So I don't need to write anything down about B. C, the sign in front of C is a minus. That means to the right. And it's C divided by B, 2 divided by 1. You don't worry about any of the minuses, just the numbers themselves. So it's to the right 2. Now, we're asked to use transformations to sketch the graph, and we want to not only sketch it, but we need to write down what's happening here. So f of x equals 4x squared. The 4 is being multiplied on the outside. That means it's A. A is greater than 1. So that means it is a vertical stretch of 4. When it's stretching and shrinking, we need at least 2 drawings of the graph. We need the parent graph and then the one that's new, that's been stretched or shrunk. So the parent graph is a parabola anchored at 0, 0. A vertical stretch means we're pulling it up, which will make the graph more narrow. And then we put stars by our final answer. The second one, h of x equals the absolute value of x plus 2. So in front of the x, invisible 1, that's B. And then since the 2 is trapped on the inside, that means it's C. Plus on the inside means we're moving to the left. C divided by B, 2 divided by 1. So left 2. And if it's only moving left or right, up and down, or flipping, if it's not stretching or shrinking, you don't really need to draw 2 of them. So if I'm going to move my V for absolute value left 2, and then here's my new V, so that's my new graph. M of x equals negative absolute value negative 8 plus 4x. If you look back at the formula that showed the A, B, C, and D, the x was in front of any number being added or subtracted. So this is a little bit out of order. We want to rearrange this and have m of x equals negative absolute value 4x minus 8. And now it will go in the right order. The minus means a vertical flip. A would be an understood 1. B is 4, the number in front of the x. C is 8. So besides our vertical flip, since A is 1, if it's 1, it doesn't stretch or shrink, so we don't have to write anything down about the A. B, a number multiplied on the inside, and it's greater than 1, so it's a horizontal shrink of 1/4. And again, you need to write all of this stuff. And then the minus means we're moving to the right. C divided by B. 8 divided by 4. You don't need to include the minus with that. 8 divided by 4 is 2. So we're moving to the right 2. We have a horizontal shrink and we have a vertical flip. Always do the stretching and shrinking last. So this is absolute value. It's a V. And it's normally at 0, 0, but it's moving right 2. And it's flipping over. So I'm going to do that all at once. Move right 2, flip over. Now the horizontal shrink. That means I'm pushing in from the left and the right, which will make it more narrow, and stars beside my final answer. P of x equals 3 minus the square root of x. There shouldn't be a number out front unless it's being multiplied. The 3 is not being multiplied, so it's in the wrong spot. This one needs to be rearranged also. So it should go P of x equals negative square root of x, and it's a positive 3. So the minus out front is a vertical flip. And then because the plus 3 is outside of the function, that means it's D. Plus is up. So up 3. No stretching or shrinking. It's a square root function. So let's move it from 0, 0 up 3. And I'm going to draw 2 of these because I think the square root function is hard to picture when you're flipping it. Okay, here's the square root function. A vertical flip is an up-down flip. So that would make it look like this. R of x equals 3 times the square root of x minus 1 plus 2. So the 3 on the outside would be a, b is 1, c is 1, d is 2. A is bigger than 1, so that is a vertical stretch of 3. You have to write all of these things. B is 1. 1s don't do anything as far as stretching and shrinking. C has a minus in front of it, so I know I'm moving to the right. 1 divided by 1, C divided by B. So right 1, and then plus 2 is up 2. Okay, and I'm going to save my stretching, shrinking for last. My square root function is moving right 1, up 2. So now it's right here. And a vertical stretch pulls. So it's kind of hard with the square root to make something look more wide, but it would be maybe something like this. And put a little star by your final answer. H of x equals 3 plus x squared. Again, you don't have an added subtracted number in the front. It needs to go to the back. So that should really be h of x equals x squared plus 3. Since it's outside of the function, that would be d, and it would be up 3. Parent graph is a parabola. We're going to move it up 3. And then that's all that one had. K of x equals 2x cubed plus 1. So the 2 would be a, and the 1 would be d. It is a vertical stretch of 2. And then the plus 1 would be up 1. So since I have a stretch or shrink, I have to draw 2 of them. It's an x cubed, so it gets moved up 1. X cubed is smile on the right, frown on the left. A vertical stretch means it's being pulled from above and below, and it will become more narrow. And stars by my final answer. Another one that needs to be rearranged, again, this 4 should go to the back. So q of x equals negative 1/2 times x minus 2 squared, and it's a positive 4. The minus is a vertical flip. 1/2 is a, b is 1, c is 2, d is 4. So we have a vertical flip. A is less than 1, so that is a vertical shrink of 1/2. B is 1, that doesn't do anything. C has a minus in front of it, that means move to the right. C divided by B, so right 2 divided by 1. And then the plus 4 would be up 4. The shrink we'll save for last. It is a parabola, and it's being moved to the right 2 and up 4. So it's anchored right here, and then it's flipped over vertically. That's an up and down flip. A vertical shrink means it's being squashed from above and below. That makes it more wide. and stars by the final answer. For patterns with functions, we sometimes look for symmetry in their graphs. So just being able to identify from a graph functions that are even or odd. Even functions are symmetrical around the y-axis. So if you folded your paper on the y-axis, the left and right sides should match up. Odd functions are symmetrical around the origin. I always think about it being pinned down at 0, 0. And if you spin the graph 180 degrees, then it still will look the same. So an x cubed graph is an example of an odd function.